Is now doing analytics at Delicato. You know Mike?
Yeah.
Oh yeah, that's right. You know Mike. So yeah, Mike is at Delicato still. Scott is in the biotech industry. Both doing well. Mike's a great guy. You guys were research assistants of mine, and they've gone on to do well. Scott actually dropped out of analytics to pursue his music career, but I think he's back in. So. All right, so the whole goal is to measure promotion. Big chunk of marketing dollars go simply to answer this question. So how do we measure promotion? Ideally, the goal of promotion is to just shift out that demand curve. Boom, boom. How do we measure it? In this simplest case, the easiest way to measure promotion is that vertical distance, that horizontal distance. So this is how much more we're going to sell on promotion relative to off promotion. And in all honesty, this is how 99.99% of promotion is measured. If they do it, it's simply, it's called promotional lift. And it's, let's see, if they do it, they're just going to throw in that dummy variable, like we showed. And beta 1 is going to be our promotional lift. So the coefficient of beta 1 is probably going to be positive, and it's going to tell us the vertical distance between those two demand curves. This is how, if they use regression, and they don't always, but if they do use regression, this is how it's done. And this is considered fairly sophisticated. There's our promotional lift. So beta 1, the coefficient on beta 1 is literally the promotional lift. We measured in units, percentages, however. The impetus for this paper was really a consulting project of mine for Treasury Wine Estates. So I was doing some pricing analytics for Treasury Wine Estates, and the head of pricing analytics told me, look, we're getting these promotional lifts. We're getting insane promotional lifts. 2, 3, 400% lift from promotion. She said, everyone knows it's wrong, but nobody knows how to fix it. So she asked me to take a look at it. So I said, all right, I'll go take a look at it. I just finished doing some work for them. And the way I work is probably different than the way most people work. Most people probably start writing out regressions, and I do this. I do the demand curve. So I'm looking at this, saying, okay, this is how it's done. Then I started to look at the data, not without running regressions, and try to see, okay, what's causing this to be so wrong? So, a couple of assumptions. One is that the demand curves are pretty much the same, so that the only effective promotion is to shift out that demand curve. The slopes are the same. So that's one assumption that is implicit when you do this analysis. And this is how you're going to look at promotion in any kind of marketing book also. The other one is that price is the same. I guess I switched these around. So one is that price is the same in promoted and non-promoted demands. And the other is that promoted and non-promoted consumers are the same. So it's really two that is reflected in the slope. The behavior between promoted and non-promoted consumers is the same. And remember that when we draw a demand curve, that price sensitivity is really reflected in that slope. So there's price, there's quantity. So let's say here is a demand curve. Here is, right, here's a quantity. Remember when we did price optimization stuff? Here's a quantity, and the highest price we can charge is this price here. We did do this last semester. We should probably. But what we can do, what we can say is, if we can just kind of rotate this demand curve and make it steeper. Right? If we can do, for example, that. So here's D1, D0, here's D1. If we could make demand steeper, let me not do that. Just change it. We can get a steeper demand curve. Then for that same quantity, we can charge a higher price. So really the steepness of the demand curve reflects the price sensitivity. How sensitive consumers are to price changes, and that price sensitivity is different from what we measure as price elasticity. They're similar, but they're different. So slope is part of the formula for price elasticity. When we draw this picture, or when you look at this picture in a marketing textbook, again, the assumption is always that those two lines are parallel, that the price sensitivity between consumers that buy off promotion and consumers that buy on promotion are the same. So consumers are equally price sensitive. The other assumption, and that's assumption 2, the other assumption is that price is the same. Because notice that we don't have any price there. We just assume promotion shifts out that demand curve, and whatever happens, happens. All right, so what happens when price is promotion combined with a price reduction? And this is addressing the first problem. All right, so here's demand without promotion. Demand with promotion. Here is our non-promoted price. So think of this as our everyday price, non-promoted price. Who's in the wine industry? Yeah, so when you're in the wine industry? No, sure. But at least in the wine industry, and this is insurance?
Yeah.
Oh, good, then the binary stuff's going to be really good. At least in the wine industry, when I look at the data, I noticed that whenever you engage in a promotion, and there are basically 3 types of promotion in the Nielsen data, feature, display. So display is any in-store promotional activities, shelf talkers, end caps, any of those things. Those are just any in-store display. Features are things like mailers that you get in the mail, buy me, this kind of, or those kinds of things. And then there's a combination that you can do both, feature and display. And then there's something called temporary price reduction. But when you engage in some type of promotion, you often lower price, which makes sense. If you're going to have a promotion, lower price, and you get that. The problem is you're no longer holding everything constant, and you're confounding or muddling up the effects of price and promotion. So when you go to measure promotional lift, basically all you observe in the data is this is what I sold off promotion, this is what I sold on promotion, and this is what your beta 1 coefficient, that dummy, is going to measure. It's going to measure that huge lift in sales. When really it's not a huge lift in sales. It's the result of 2 things. It's the result of 1, promotion, but 2, the fact that you lowered price. And as soon as I drew this picture, it hit me what the problem was, and it hit me what the solution was. So we get this is why we're getting these huge overestimates of promotion. So how do you isolate the effect of price from promotion? How do you separate those 2 things out? by training, at least in grad school, I was one of my fields, I was a labor economist, labor, public policy, and econometrics. And in the field of labor economics, there is a paper that tries to analyze the wage differentials between men and women. And what this guy, Ron Oaxaca, was trying to do, this is actually his PhD from Princeton University. So what he was trying to do is say, look, we know men and women make less. Women make less than men. So we know that. But part of that might be because women have acquired less skills. So because of childbearing, they're in and out of the labor force, and perhaps they didn't acquire as much schooling as them. So this paper was written, I think, in 1969. It eventually was published in 73, or maybe it was 71 that was written as his dissertation. And at the time, women did have less schooling than men. Women went to college degrees less frequently. Now, actually, women get college degrees more frequently than men. So he wanted to say, okay, how do we separate the fact that women acquire less education and are in the labor force less because of childbearing? How do we separate that out from the fact that they may be discriminated against? We don't want to combine those two things because it's going to look like discrimination is a lot larger than it actually is. So what he was trying to do is just trying to measure the true measure of discrimination. And basically what he did was he looked at demand curves for males and females and said, and was able to decompose the two effects. So what I did was I just kind of thought, as soon as I drew this picture, I thought, okay, this is a decomposition problem. So basically what he does is he says, remember, all we observe are two things. We observe this price and this quantity, this price and this quantity. What we can do, however, is since we are running regressions, we can analyze points that never really exist in the data, right? We can forecast. That's the whole idea of predictive analytics, is to use the model to predict what would have happened in these other circumstances. So what we can do is identify the quantity that would have been sold at the lower promoted price along the non-promoted demand. Specifically, we want to identify that point there. That point reflects the lower promoted price, P1, but on the non-promoted demand. So if the firm had simply lowered, price, sales would have increased in the absence of promotion. The rest of that is going to be due to the promotional effects. So this point here is a hypothetical point that once we estimate this demand curve, we can find that point, and then we can say, okay, this much of that promotional, of what we were calling that total lift, is due to the fact that we just lowered price. It would have happened irrespective of promotion. This part is going to be the lift due to promotion. And depending on kind of the size of the price reduction and some other things, these can be of very different magnitude. So, I mean, this is really the main breakthrough of the paper was this had never been done before. This is why promotional lifts were exaggerated and higher than they really should be. So the question was, okay, can we do this in practice? And it turns out, yeah, we can. So what we can do is basically I whipped out the Oaxaca paper. Juan Oaxaca, again, Princeton, PhD, and now teaches at the University of Arizona. Nice guy. Nice guy. Actually, a couple of my students from here have gone to Arizona to get their PhDs and wrote under him. So basically, we can estimate this demand curve, estimate a non-promoted demand curve. We can estimate this demand curve, estimate the promoted demand curve. So I basically stole this methodology straight from his paper. And we observed this total increase in unit sales. So that's that total effect. it's basically, we're gonna subtract promoted from non-promoted demand. This is where things get a little bit hairy. This is probably why you don't remember it from 580. All right, so what do we do? How do we do this in practice? We estimate a promoted demand, there it is. And don't worry about the chi, because that's just going to be the other factors. Things like in our paper, like months and those kinds of things. Then we estimate a non-promoted demand. We know that the difference between those two is that promotional lift. Right, not the promotional, is the total effect, which includes both promoted and non-promoted demand. And that's all I'm doing here, is taking non-promoted demand, the promoted demand and non-promoted demand and subtracting it from the promoted demand. So that's all that is. So it looks fancier than it is. Then I did this little trick. I didn't do it, actually he did it. But I stole this little trick. I identified that hypothetical point. So this is that non-promoted, so the coefficient for the non-promoted demand curve evaluated at the promoted price. So price P is promoted. So I'm going to take that term and add and subtract it to both of my terms, both of my demand curves. This is what he does. And here it is here, subtracted. Here it is here, added. Then we go through, then we just basically collect terms. Rearrange, collect terms, and we have the difference in the intercepts. We got here, which is the difference. Let's kind of rearrange this some more. Just notice that I have an extra parenthesis there. Yeah. So, again, difference in the intercepts, which measures the shift. The difference in the, let's see, BP minus BN, yeah, the difference in the slopes, and the difference in the price, and the price coefficient. And if we evaluate that term, then that measures the promotional effect. The price effect is just evaluated with that. It's the difference in the prices times the coefficient on price in the non-promoted demand curve. This is his famous paper. Again, I literally stole it from Oaxaca's paper, applied it to something new. All right.
What was okay, sorry, I was writing when you were talking. The first part, the first beta is that's the shift, and then the second portion of the equation at the promotional effect.
Yeah, so this whole term, all these combined together.
Yeah, but the first one is the shift.
Yeah, this is the difference in the intercepts.
Yeah, and the second one.
So this is the difference in, kind of ignore this because these are like the dummies.
Yeah,
So
okay.
ignore this. But really the main part is here. This is the difference in the slopes evaluated along the promoted demand.
Okay.
The difference in the slope coefficients.
Okay, thank you.
And if there was no price difference, so if these prices are the same, then this term disappears, and then we're back to that simple case where we have two parallel lines. So the idea that right, this is true, excuse me, measuring promotion as this vertical, horizontal distance, QN, QP. Measuring that is true if two things are right. One, the slopes are the same. And two, there's no price difference between promoted and non-promoted price. But in the wine industry and other industries as well, again, lowering price is part of the promotional combination, the marketing mix combination. So they go hand in hand, and at least when I looked at the data, I couldn't find it, at least for Treasury, I couldn't find any examples in which price wasn't reduced during a promotion. It's just always done that way. The problem is that the two results get muddled and we get these big returns on promotion. This, however, decomposes that. It takes out the effect of promotion from price, and we're able to isolate the pure effect of promotion. All right, so here's some data, and I already said it was it Treasury data?
Treasury owns a zillion nothing stuff, so
Yeah.
it could be anybody's minor.
Yeah, so it's an anonymous in the paper, I just call it an anonymous cap. And we can see that kind of overall, the difference between promoted and non-promoted prices over $1. And then within each of those, feature display, feature and display, and TPR, temporary price reduction, we see that all of them have, the lowest one is $8.18, which is again more than $1. So when you promote, you generally lower price, and that makes it difficult to get an accurate measure of promotion. How effective was my promotion? I don't know. If it was also accompanied with a price reduction, could we have achieved the same sales if we just lowered price? That's really what the question is. So here's a simple case in which I estimate the two demand curves, right? I estimate a non-promoted demand curve and a promoted demand curve. And I guess the first thing we should notice is the price coefficients are very different. The non-promoted demand curve is a lot less than the promoted demand curve, which means that consumers that buy on promotion are much more price sensitive. Remember the literal interpretation of these price coefficients. For every $1 increase in price, consumers will buy 976 fewer cases per week. On promotion, however, consumers are a lot more sensitive to price. For every $1 increase in price, they're going to buy almost twice as much less, 1,700 fewer cases as opposed to 976 cases. So people that buy off on promotion are very different than people that buy on promotion. But we haven't really addressed that yet. All right, so here is, here's the regression, price constant. Here is our formula. I did the decomposition. The total difference in sales was, which we've been mistakenly calling promotional lift, is 1,500 cases per week. And this is a pretty high volume wine too, so and it looks like our percentage lift is about 50%, which is pretty good. So if you're getting a 50% lift, that's impressive. All right, so I just pulled out the formula. The difference due to price is most of that. 45% of the 53%, or let's just say 84% of this, was due solely to price, which means the rest is what's due to promotion. We plug that in, it means that the true promotional lift wasn't 53%, which is impressive. It's only 8%, which is very, very different than 53%, as you can imagine. So I'm thinking I'm getting a 53% increase in sales due to promotion, which means my promotion manager or whatever, marketing manager is doing a great job. That's very different from saying, well, no, sales are only increasing by 8%. Most of that lift was due to the fact that you lowered price. We could have saved money. Well, if we had simply lowered price to whatever we did in these promotions, we would have gotten 84% of that lift. We would have gotten a 45% lift instead of 53%. Remember, these promotions cost money, right? Every time we hang those shelf talkers and bottleneckers and all those things, all those promotional activities, features, mailers, all those things cost money. So maybe it was worth it at 53%. At 8%, it's probably not worth it as much.
Because they have different slopes though, isn't it going to be different at different points along the curve?
Exactly, which is the other brilliant insight from the paper.
Who wrote that paper?
So, yeah. So the first insight of this paper was accurately measuring promotional lift. That's the true promotion, as opposed to the fake. We got fake news, now we got fake promotional lifts. So that's there. All right, heterogeneity is the fact that the slopes are different. So again, textbooks, so this is how promotional lift is measured. Again, what I said is what happens if this is an invalid assumption? What if they look like that, for example? The slopes are different, like that. You know, that's the other. And this makes sense. You know, the strange thing about this is a huge controversy in the marketing literature. And there are really two camps. I think there was the Yale camp, and then there was the, I forgot what's Yale's, or maybe Wharton versus Yale's, I forgot what Yale's business school is. But there were these two camps battling this out. And no one had really definitively said what is what. Because no one followed the approach I did. But what would cause these curves to be different? And basically I said this can be caused by two things. One, promotion induces consumers to behave differently. And my best example of this, and I really should embed a video in this, my best example of this is, what's that? Oh,
Sorry.
what's the one coming up? Friday. What's the Friday thing called?
Black Friday.
Black Friday. It's Black Friday. Yeah, it's Black Friday. Every year we see this on the news. Either someone gets trampled to death for a $20 CD player, or DVD player. One year I saw this lady get squirted in the eyes with pepper spray. Yeah, I've seen this on the news. I just gotta put these in here. And that's saying that promotion makes people go crazy. Like, oh my God, there's this huge sale, there's a promotion, people go nuts. And, you know, thinking about those Black Friday sales and what happens then, people literally getting trampled to death, people literally getting sprayed in the eyes. I think, if I'm not mistaken, someone actually got shot over one of these. And you're talking about
Last year or 2 years ago, something like that.
yeah, someone got shot. So that's just crazy. It makes this even more ridiculous. Like, people are very different. Maybe. The other could be that it just induces different people in the market. In other words, it's not people that are behaving differently, it's different people. And this makes sense also. I'm sure you guys know some, like I said, I just spent 2 weeks with my mom, so. But my mom will spend $40 in gas to save 10 cents on a box of whatever you buy in a box of cookies or something, right? And she'll buy the cookies at Safeway. She'll go 40 miles in the opposite direction and go buy bread at Lucky's in Morgan Hill because it's on sale there. In other words, there are some people that will only buy stuff on promotion. And again, if you know anyone like that, it makes sense that these two groups, this could very conceivably be two different groups of people. People like me here that don't buy on promotion if you put a gun to my head. And that's almost literally true because sometimes, like the shelf talkers, Sometimes you'll go buy something at Safeway, and there will be an instant coupon. You pull it out of the little tab thing, you know, like when you go to the deli, you pull the tab. You can literally grab a box of cereal and pull out a coupon and say 50 cents. How many people never do that? I don't. I will never pull that out, and they're just giving me 50 cents. It's just, here's 50 cents, take it. I'm like, no, you have it. I don't know what it is, it's some sort of mental defect, but I'll just refuse, I refuse to use coupons. And it's, yeah. So what do? I get charged more. It's fine. But there are some people that are the opposite. They refuse to buy anything unless it's on sale. And sometimes they'll buy stuff that they don't even need if it's on sale. And again, my mom will hand me a box of graham crackers because she bought 10 of them because they were on sale. I don't like graham crackers. I'm not going to eat them. Yeah, I got a whole bunch of them. They're on sale. Take them with you on your trip back there. You can eat them on the car on the way back to Sonoma. And then throwing them out the window. But it's not inconceivable that these can be two different groups of people. It doesn't matter which one of these is true, or a combination of the two, but we do know this, that the demand curves for those two are probably different. Making this assumption is I think this is more of a stretch than that. And when you run, I can put this back, when I run this model, quantity equals beta 0 plus beta 1 promotion plus our error term. When I run that model, here's the price, I guess we're going to put the price in here. There is no other result other than this picture. Even if these are different, this model will only estimate two parallel lines. This is the equation of the two parallel lines that should have pricing. So there is no way to get anything other than these results if I estimate that. The only way I can get two different slopes is I need an interaction. And I need to interact price with promotion. But, as she said, if this is true, then you're going to get, so what are we doing here? Heterogeneous consumer is different, promotion is going to have different effects at different prices. And kind of appeal to this reference pricing idea of reference pricing. In other words, we know what is and isn't a good deal. When I go buy a bottle of wine, and I do try different wines, but in all honesty, there's a handful of wines I buy, and I buy them on a pretty regular basis. St. Francis Old Vines Inn, Benziger, Sonoma Cab, Alexander Valley Cab, a lot of Chateau St. Jean, because I usually buy Glenallen Kenwood products. So there's D.R. Cohen there, so there's lots of wineries, but there's ones that I drink on a pretty regular basis. I was in a